Okay, so now in today's lecture, we are going to it's not it's going to be a comparatively short lecture, and our objective would be to try to solve some of the problems related to the hydraulics, uh, fluid power systems that we studied. So before moving towards problem solving, let's first see some of the formulas associated with it. Since within the hydraulic system, we are going to have a linear actuator. The linear actuator will be the linear cylinders. We are not really focusing over about the rotating cylinders or rotating actuators at this stage. But for the case of linear cylinders, the things that we need to consider are the force, velocity, and power needed. Okay, so let us see for the case here. When we have an extension stroke, in case of the extension stroke, the fluid is coming entering at side A, and the fluid at side B is going out. So we have a fluid inlet at side A, and we have fluid outlet at side B. We have a piston here in the center. Uh, then we have a cylinder, barrel of the cylinder. The piston is connected by a piston rod, okay, and the which is connected to the load, and we have an extension stroke here. So in case of the extension stroke, okay, the theoretical thrust force or push force during extension is basically the pressure on the A side, side A, multiplied by the piston area. The piston area depends upon the bore diameter, the piston diameter. Okay, so that will be P into pi by 4 dP square. Okay, when we are talking about the theoretical velocity during extension, so for the velocity can be determined using the volume flow rate. The volume flow rate formula is Q equals to AV. Area will be the piston area multiplied by the velocity of the extension. So the velocity of the extension will be QA divided by AP. Okay, where AP is the piston head side area. VE is the velocity of the piston during extension, and QA is the volumetric flow rate at side A. Then the next thing we need to find out is the power during extension. How much is the power during extension? So power is basically force into velocity. Okay, so force of extension multiplied by the velocity of extension. Now force of extension can be written as P pressure multiplied by area. This is the force of extension, and the velocity by the formula Q equals to AB, it will be Q upon A. Now AP will cancel in it. So we'll have the power of extension equals to the pressure PA multiplied by the volume flow in, volume flow rate of the volume flow in. So these are some of the basic formulas that we are going to use here. This is for the case of extension. Okay. So similar formulas are there for the case of retraction. In case of retraction, what happens is that the fluid inlet side is changed. So instead of having the fluid inlet at side A, we have now fluid inlet at side B, and fluid outlet will be at side A. Okay. The In this case, the theoretical tension force or pull force during the retraction is given by uh, the pressure at side B multiplied by the area. Now, area here will not be the complete area of the piston because we also have a piston rod here. So we have to subtract the area of the piston rod from the bore area of the cylinder. So if the piston piston diameter was dp and the rod diameter is dr, so then the annulus area will be actually pi by 4 dp square minus dr square. So this will be used in the formula to find out the theoretical tension force in case of the retraction. Theoretical velocity will be again QB equals to AR into VR, or VR will be QB over AR. Okay, so AR will be the piston rod side area. So rod side area, that will be the annulus region area. Annulus region area will be this area. Then power during retraction will be again force into velocity, or we can write here in the form of pressure multiplied by the flow rate. So these are some of the basic formulas that we are going to use to solve the problems for related to the hydraulic power systems for the linear actuators. So let's see a problem here, a 10 centimeter hydraulic cylinder. So 10 centimeter is basically the diameter of the cylinder. Has a 5 centimeter piston rod. So the diameter of the piston rod is 5 centimeter, receives a flow of 100 liter per minute at 12 megapascal. Find the following: extension and retraction speeds. So we need to find VE and VR and the extension and retraction load carrying capacities. We also need to find FE and FR. So we have these parameters in the basic SI units provided with us. Since the volume flow rate was given in liter per minute, we can convert it into meter cube per second. And we have the pressure in megapascal. So the first thing is, since we have the basic formula Q equals to AV, so for the case of extension, we can use the piston area and we can use the volume flow rate to find out how much is the velocity of extension. Okay, then we can find out the velocity of retraction. In that case, we have to use the rod side area. Rod side area will be the annulus region area. Okay, and substitute the values into it. The volume flow rate would be the same. So we can get the velocity on the for the case of extension as well as for the case of retraction. And then once we have the velocities, then we can find out the force. The force equals to the pressure multiplied by the area. So for the case of extension, it's the pressure multiplied by the area of the piston. We can find out the force, and then for the case of retraction, it will be the pressure multiplied by the rod side area. That will be of the annulus region. Substituting the values, we can get what is the force on the retraction side. So that was the solution to this problem. It's a simple problem comparatively if you know the formulas. These formulas will be, in fact, these formulas will not be provided to you. So you have to memorize these formulas because these are very basic and simple formulas. So they will not be provided to you in the exam if a problem ever, if a problem comes related to it. Now let's see the another problem. A pump supplies oil at 0.0018 meter cube per second. This is the volume flow rate of the oil to a 50 millimeter diameter double acting cylinder. Double acting, as I told you, we can have a single acting and a double acting cylinder, but double acting will have the pressure side fluid can inlet can be there on either side of the piston. Okay, so to a 50 millimeter diameter double acting cylinder, if the load is 6,000 Newton, that's the load extending or retracting, and the rod diameter is 25 millimeter, find the following. What will be the hydraulic pressure required during the extending stroke, piston velocity during the extension stroke, cylinder power in kilowatt during the extension stroke, hydraulic pressure during the retraction stroke, piston velocity during the retraction stroke, and the cylinder power during the retraction stroke. So we have the force with us, we have the volume flow rate with us, and we have the diameters of the piston and the rod. So we need to find out the forces. We need to find out the hydraulic pressures, the piston velocity, and the power. So hydraulic pressure is basically pressure is force over area. So since we know the force and we know the area on the piston side, so we can find out what is the pressure on the piston side. Q is equals to AB. We are going to use that to find out the velocity on the piston side. And power will be force multiplied by the velocity. If we know the force in the for the extension case and the velocity in the extension case, we are going to find out the power on the extension side. In the same way, we are going to solve the problem for the case of retraction stroke. For the retraction stroke, area will be the annulus region area or the rod side area. Since the force is the same, so we are going to find out what is the pressure in the case of retraction side, and we can find out the velocity correspondingly. And once we know the velocity and the force, we can find out what is the power needed uh, cylinder power during the refraction stroke. Okay, let's see another problem. A hydraulic cylinder has a rod diameter equal to 1/2 of piston diameter. So we have a rod diameter equal to 1/2 of piston diameter. Determine the difference in load carrying capacity between extension and retraction stroke if the pressure is constant. What would happen if the pressure were applied to both sides of the cylinder at the same time? So we have the given data is the diameter of the rod is equals to 1/2 the diameter of the piston, and the pressure is constant. So we need to find out the difference in load carrying capacity and what would happen if P is applied both sides, if P is applied both sides at the same time. So we have the formula uh, for the force is pressure into area. This is for the case of extension. This is for the case of retraction. Now, if the diameter of the piston is twice the diameter of the rod, then we can have the relationship for the areas. And so we can have the relationship of area for the rod side area for the rod and area of the piston. Now we can take the force ratios in the extension and for the case of retraction. Okay, substituting into the main formula. Okay, PP will cancel here. So we'll have AP over AP minus AR. AR can be presented in terms of AP. AP is going to be taken common from the numerator and denominator. They're going to cancel each other. And so we can have a relationship between FE and FR. Now what we need to know, we need to know that what will be the difference in load carrying capacity. That will be FE minus FR. So if we substitute the values, okay, so the FE minus FR would be approximately 1/4, 1/4 of the P multiplied by AP. So that was this answer to this solution if the pressure was same on both sides. Okay, now let's see this last problem. A cylinder with a bore of 100 millimeter and a piston rod diameter of 50 millimeter has to extend with a speed of 8 meter per minute. The pressure applied is 200 bar. Calculate the flow rate in liter per minute of oil to extend the cylinder, the flow rate in liter per minute from annular side to extend the cylinder, the retraction speed in meter per minute using the part A answer, and the flow rate from the full bore end to retract. So we have the basic formula Q equals to AV. We are going to apply that to find out what will be the flow rate to extend the cylinder. We know the diameter of the cylinder. We know the velocity of extension. So then the next thing would be to find out the flow rate from the annular side to extend the cylinder. So from the annular side, we will be using the area AP minus AR. Since we know the diameter of the bore as well as the diameter of the rod, so we can use that to find out what will be the flow rate. Corresponding to flow rate, we can find out what will be the velocity, the retraction velocity. And if you want to know that what will be the flow rate from the bore and from the full bore end to retract, so it will be here we are going to use the AP, which is the area of the full bore end, multiply by the velocity of the retraction. So we are going to get the flow rate in that for that case. So this is the solution of these problems. So these are some of the problems for designing the hydraulic systems discussed. If there is anything regarding the solution of these problems which is not clear to anybody, please feel free to ask. Otherwise, this lecture is over.